Okay, so let's talk about this. So in 8.3, we're sort of still talking confidence intervals, right? That's where we started this whole thing. Yesterday, we talked about proportions confidence intervals. So let's just talk real quickly. What does that look like? And so again, jot down as much of the notes as you need to. And again, this will be recorded so you can always find it online. So we talked yesterday, if we get a sample p-hat, right? Somebody gave us, we went out and we took a sample of 30. We looked at the p-hat. We looked at the proportion of students who blank. And then, but we said, don't just report that value. Also report an entire interval of values, right? So we talked about using this, and so this was the formula that we talked about yesterday. We say that you're going to do p-hat plus or minus z star times this formula, right? So this formula you should have written down by now. It is also on the formula sheet. So if you go to the formula sheet that we have on the Google Classroom, you'll also kind of find that generic formula there. So this was, though, very specific for proportions. So today, what we're going to do, we're going to move from proportions, because proportions are great. I want to find out what the proportion of students who play a sport at Lake Ridge High School. That's a good question, right? But sometimes we want to know things like what's the average GPA or what's the average height of students at Lake Ridge High School. And if we're looking for that, we're no longer looking for yes or no questions, because I'm not going to go to somebody and say, hey, how tall are you? And they're going to say, yep, right? That doesn't make sense. So we want to get a numerical value. But so when we get a numerical value, we're going to be looking at things in averages, right? So we're going to start looking at X bars instead of P hats on this here. So we're going to do the same fundamental idea, is we're going to build intervals around means instead of intervals around proportions. Right, so that's what it's going to look like here. So we need to do the same thing, though, that we did yesterday. So this is why I was talking about kind of our generic structure is important. So when we do a confidence interval, we panic, right? So when we do a confidence interval, we panic. But I always want you to connect those two things, confidence interval and panic. And most specifically, the A, the I, and the C, right? What are the assumptions and checks that we need to do? What does the interval calculation look like? And then what conclusion do we write on there? Right, so that's what we're going to be working on. So we are focused on means now instead of proportions. Structure is the same, slight differences in there, all right? So let's talk about this. So here's the weird thing about means. There are two different kinds of means problems that we're going to do. So we are going to do, so I'm going to try to see if I can do this. So we're going to do a means Z interval, or we're going to do a means T interval. Oops, that's not how you spell interval. Right, so there's two different styles of means intervals. One is a Z interval for means, and the other is a T interval for means. A Z interval for means that we're doing normal curves, right? Oops. We're doing normal curves. So that's a Z. And T interval means that we're doing that T distribution. Remember, this is back in chapter 7, we talked about this thing called a T distribution, which is, it's a distribution that wants to be normal, but it's not. Right? It's kind of normal, but it's not truly normal. It's its own little thing. It gives us more room for error. So we're going to have these two different pieces. So let's talk about the difference between them. So let's talk about the assumption checks for each of these. So I'm going to write these down. I'm going to go kind of quickly through it just because they were the same things that we did in the video so that you can kind of go back and look at that. But if it's a Z interval for means, remember there's 3 checks we always do, just like we did for proportions. 3 checks. One is, can I do the curve? Number 2 is, is the bias check, and number 3 is the independence check, right? So it's the curve check, the bias check, the independence check. So number 1, in order to use the normal curve, we need n to be greater than or equal to 30, because we know that there's a thing called the central limit theorem that kicks in. And again, I know that's making us track back to chapter 7. Remember, we talked about this thing called the central limit theorem that says that as long as my sample size is big enough, 30 or greater, then the central limit theorem guarantees normality, right? So that's going to be the first thing we're going to look for if we're doing a z interval. Number 2, right, the bias check, we're always going to be looking for random. And then number 3, the independence check, we're going to be looking for, or we're going to be using the 10% rule. Right? So nothing too new about that. But the question is, when do I use a z interval and when do I use a t interval? So the style of interval that you use is all based on what is given to you. So I'm going to put this right here. So z, we're going to use that if the standard deviation of the population is given. And remember, the standard deviation of the population is a Greek symbol. Anytime we use Greek symbols, we're talking about a population. So we use this Greek symbol theta. If they gave me theta, I get to do a z interval. If they don't give you theta, if only the standard deviation of the sample is given, that's the little s value, then we're going to use a t interval. All right, so there's going to be, I know that's kind of getting small on the screen, but that's the basic idea of what we're doing so far, okay? So it's a means problem. They're giving me a standard deviation. You need to check where that standard deviation came from. Did it come from the population? Then do a z interval. Or did the standard deviation come from the sample? Then do a t interval. Okay, let's go through the assumption checks real quick. What if it's a t interval instead of a normal interval? Then we need to do what we call a t check instead of a normal check. So do a t check instead of a normal check. And really, it's really got a couple things. If n is greater than or equal to 30, sounds very similar to normal, then what we say is t distribution is robust. And remember, we use that term in chapter 7 as well. It just means that the t distribution is going to be good and it's going to be able to handle extreme values. So t distribution is robust. If n is less than 30, we need to look at the data. Let me try to really zoom in on that. We need to look at the data and see no outliers and no extreme skew. All right, so there's with a t check, right? So we're going to do that, and we're only going to do that if they give me the standard deviation of the sample. So that's going to be what we're looking for there. Okay, so very much like a z interval, it's got a check, and then it's got number 2, it's going to have a bias check. Number 3, it's going to have an independence check, but we know those are exactly the same, so we're looking for a random, and we're looking for the 10% rule. Okay, so it's a slight difference so far. It's literally just a quick check, right? Am I doing a normal? That's called z. Z is normal. Or am I doing a t? We'll check that you can do the t distribution. It's got a little more of a more depth check, but it's not too much more extreme of a check that we have to do on there. So that's what that looks like right there. Okay, so that's the A part of panic. Let's talk about the I part of panic. Oops. to the I part of panic. That's the actual interval calculation. So let me show you what these interval calculations look like, and they're super, super similar to each other. It's going to be x bar plus or minus. If we're doing a z interval, we're going to find a z critical value. And that means we were using the standard deviation of the population divided by the square root of n. That's what that interval will look like. If we're doing a t interval, it's going to be x bar plus or minus t star, t critical value instead of a z critical value. And that means we're doing the standard deviation of the sample divided by the square root of n. So notice the slight difference in those two right there. Right, so slight different, and again, it's all going to come on the awareness on where is the thing coming from. And then at the end, remember our conclusions are always going to sound the same, and it's going to sound very much like it did just yesterday. So I'm going to give you the very generic. It's we are blank % confident the interval from blank to blank captures the true mean of, give some context. That's it. That's your overall formula right there. That is the format, and we'll just process that. So I'm going to do a problem with you guys, and we're just going to knock this out and have a good looking problem to look at. And then, like I said, we'll do another problem where just have you kind of work ahead of time and then see if we're on the same track. Now, here's what I'm going to say. If you don't know, should I be doing a means z interval or a means t interval? Do a t interval. It's most likely going to be a t interval. So that's just a little side note you can make for yourself. If you're ever not sure, you're like, I can't even tell, let's stick with the t interval side. All right, let's do this stuff right here. Because most of the time it's a t interval. It's not realistic to have a z interval in real life data sets. Okay, so let's look at a data set and let's see if we can process this, because I need to talk about how to get that t value on there. So here we go. I'm actually going to skip number 1 for a minute. I'm going to come back to that in a second. So let's go right to this number 2. This is the problem that we have available to us. So it says, biologists studying the healing of skin wounds measured the rate at which new cells closed a cut made in the skin of an anesthetized newt. Here are the data from a random sample of 18. All right, here's one thing that we see. Random sample of 18 newts measured in micrometers per hour. So they give us the actual data set. It says calculate and interpret the 95% confidence interval for the mean. So whenever I hear calculate and interpret a confidence interval, remember there's my key that I need to panic, because that's what they're telling me to do, right? So do that. And here's your key word, mean. So right away, I know this is a means problem. I know I'm doing a confidence interval. Second question, do I do a z interval or a t interval? Because means can go either direction. So then you look back at the data that's given to you and you say, did they give me the standard deviation of the population? So you go back and you read this. Nowhere in here did they give me the standard deviation of the population. Therefore, this thing is a t interval for means, because I have to use the sample standard deviation. Okay, let's let our calculator do some work for us for a minute. If you want to, so again, this is on LinkedIn there, because it might be hard to look back and forth. But if you want to, I'm going to try to build those up. There's 18 different values in there. So let's go ahead and put those into your list in your calculator. So if you have your calculator, I'm going to go to Stat, Edit. So hit your Stat button, hit your Edit button, L1, and clear any data that's in L1. And let's just put the data that's here. Let me give you a moment to do so. All right, so I'm putting all this data set into my L1. Before I use it, I just want it there for a minute. Just want that in the data set. And I'm going to think panic for a moment. All right, so the A part of panic. So again, there's three parts that you literally have to write down, right? You have to write down the A, you have to write down the I, you have to write down the C. So those are the three pieces. Since I recognize that it is a T interval, then I just need to put things appropriate to a T interval. So let's start with the A. So there's three checks we need to do, the assumptions and checks. Number one, since I'm trying to do a T interval, I need to do a T check. And the main qualifier is my values, my sample size is less than 30. All right, so if my sample size is less than 30, what we just wrote down, you know what I need to do? I need to check the shape of the data set. So here's how we want to do it. In your calculator, and again, I'm going to do a lot of calculator stuff this semester. So we want to work with our calculator. So in my calculator, I'm going to go second your y equals button and turn a stat plot on. Let me see if I can, let me put this over. So again, I go second, then I hit that y equals button. And I want to turn plot 1 on, and I want to do the histogram. So I'm going to do in plot 1, and you're going to look across until you see the little histogram looking symbol thingy like this. Right? Go ahead and highlight that. It should then, underneath it, it should say, where's your X list? I put all my data in L1, so if you put all your data in L1, tell it it's L1. Frequency is 1, perfect. Now, from here, hit your graph button. Once all that's filled in, hit your graph button. And then, typically it doesn't straighten it up so well, so then hit your zoom button. And go down to number 9, which is zoom stat. And then hit enter. And see if you get a histogram show up on your calculator, right? You should get a histogram show up on there. So second, y equals, plot 1, turn it on, make sure it's pulling from the right list. Then hit your graph button. Then hit your zoom button. I guess this is a button. Graph button, zoom button, go down to number 9. And you should get a histogram. Here's what my histogram looks like, just so that you can see if you're getting something similar. So my histogram looks like that, right? You should be getting something similar. Just let your calculator do its job. It's saying like, hey, you tell me to build a histogram, I'm building a histogram. So on an actual AP problem, here's what we would need to do. Under my number 1, I say an n is less than 30. Then you're going to literally draw a quick picture of your histogram. It doesn't have to be perfect. You don't have to be an artist. If you are, make it look nice. You're just literally going to draw the histogram you see in your calculator, because an AP grader doesn't know if you're looking at a histogram or not, or you're just faking it. So you draw the picture of what you see, and they would be like, oh yeah, you did see it. And then let's make a few comments. Here's one of my comments. No outliers. I don't see any outliers on here. And I'm actually going to say no skew. I don't even really see much of a skew at all. Maybe you could get away with calling it maybe a slight right skew. But what's the things I'm really looking for? I don't want any outliers. I don't want any extreme skew. I think we're going to be okay. I don't see those two things happening here. No outliers, no skew. All right, guess what? That's called a check. So go ahead and check it off. We're good to go. We're allowed to use the t-distribution. That's what we're basically saying. We have allowed the check to come through. All right, number 2, let me go back to the problem. What's our second check? We always want the word random in there. And guess what? I see the word random sample. So we're good there. I'm going to put a little check mark here. That's my bias check, right? I want to make sure that it was unbiased, so make sure that it does not say random sample on there anywhere. Okay, and then number 3, since we're sampling, we always want to check the 10% rule, right? right? They sampled 18 newts. I don't even know where they got the newts from, so we're going to say, how about all newts? If I multiply my sample by 10, do we believe there's more than 180 newts out there in which to sample from? I think that's a safe assumption. Okay, there we go, right there. There is the A part of panic. Always need to set up my entire thing. So I'm set up. I'm allowed to use the t-distribution. It should be unbiased, and my interval, my standard deviation calculation should work. That's that third check, right? As long as it's independent, my calculation should work out. There's my assumption checks. Okay, let's move right into the next piece. That's the interval calculation. So interval calculation. I'm actually going to I need to use some processes out of here because right now I don't know my x bar, I don't know my s value, but it's in your calculator, right? Your calculator is ready for it. So let me go back to our data set, right? So we put everything into L1. So let's go back to stat, and let's go ahead and let's start to process this. So let's go stat. Let's slide over to tests, and then let's go down until we find a thing called t interval. All right, that's the one we're looking for, t interval. So go find that, hit enter. Now once you get into t interval, you have two options on this. You have a data option and you have a stats option. So it's really just saying, do you have a data set available for me, or are you just going to give me some numbers to process? In this case, we do have an entire data set to give the calculator because we've already put it in there. So if you do data set, hit enter, right? It'll highlight it. It'll say, okay, good, we're going to go with data. In the list, tell it what list you put your data in. I put mine in L1. If you put yours in L1, go ahead and let it say L1. Frequency, always leave it 1. Confidence level, let's go back. It says interpret a 95% confidence level. Okay, so then, let me do this again. Frequency, let's always leave it at 1. And then our C level is 0.95. And then go ahead and calculate. Now it's going to give you a few things you need. It's going to give you first the answer and second the stuff that you need to fill in as if you are doing the answer by yourself, right? So look at your calculator. You should have an interval, right? You should have a lower bound, upper bound, and it should also have an x bar value and an s value. So that's what we should have. So let's do interval calculation. Okay, so first thing that you need, look at the actual formula for interval calculation. You need the x bar, which I'm looking at my calculator right this second, it's 25.67. Again, there's no requirements for rounding in stats, so you decide what you want to round to. Plus or minus some t critical value that I'm going to have to go look up in a second. So let me go look that up in just a second. Times s, which is 8.32 divided by the square root of n, which is 18. Right? So there's what the formula looks like right there. The only thing that we have missing right this minute is this. We do want to know how to go look these values up. So this is where we're going to turn to our table of values, right? So our T table, our table B. So if you want to electronically, you can go to it. If you have and I would recommend starting to print them out. In the old days, I just print them out, right? So I would always have like my formula card so that I can always go to table B, right? But I would recommend, having a printout of these. It's nicer to have a printout, but you don't have to, because actually I don't have it right. I mean, I do have this right here, but a little note. So write a little note here. Ooh, I am running out of space. Write a note here that says on the table, on the table B, use infinity line for all z intervals. That means z interval for proportions, because they're always z interval. And that means z interval for means. Every once in a while, we'll have a z interval for means. Always use the infinity line. If it's a t distribution, you have to use any number above the infinity line. So we need degrees of freedom. This is this thing called degrees of freedom for this, all right? So here's what we're going to do. I'm going to add a little note in here real quick. So I need a degree of freedom in order to find that t critical value. So degree of freedom is a pretty easy calculation. Degree of freedom is n minus 1. So let's take it for this problem right here. Remember, there was 18 sampled. So the degree of freedom is 18 minus 1. So the degree of freedom that I care most about for this problem is 17. Now, why is that important? It's only important for the critical value. So let's go look up a 17 degree of freedom with a 95% confidence interval. So I'm going to go to my table B, and I'm literally going to find where those two meet. So let me check the table. So after looking it up on the table, I got 2.110, where 95% meets 17 degrees of freedom. That is the number that's sitting there. Okay? Right? So the idea is, if your degree of freedom is not listed on that table, use the degree of freedom that came before it. So a degree of freedom 56, I'd use the degree of freedom 50 line and do that. Okay? So there's our interval calculation. Now I didn't actually need to calculate, or I'm not actually going to calculate it by hand because I got it right here in my calculator. So now literally I'm just going to write the calculation like we see it. So 21.527. That's my lower bound. 29.806, that's my upper bound. This is good enough for AP credit now, right? You showed the X bar, you showed your T critical value, you showed the standard error, which is what's in blue right there, and then you showed your actual interval. So since you have all that, the last thing you need to do is put a conclusion together. So let's do the last part, conclusion. We would say this: we are 95% confident the interval from 21.5 to 29.8 captures the true mean, what are we looking for? Healing rate. True mean healing rate. Right? There's my context right there. But that's what it sounds like all the time. So I'm 95% confident that it captures the true mean healing rate. So again, there's this idea of this is my actual interval. I am 95% confident that this interval captures what I'm looking for. And if somebody said, well, what does the 95% confidence mean? It means that if I did this process 100 different times with 100 different samples, 95% of those samples would capture what we're looking for. So since we did one, I'm 95% confident that this is one of the ones that captures what we're looking for. All right? So there you go. That's a full-out panic problem. We want to know how to do that. And then let me just go ahead. I'm going to actually back up now. I'm going to go to the number 1 that's on the worksheet, because this is the work backwards. So we did this yesterday. We did it with proportions. We did a panic problem with proportions, and then we did a work backwards problem with proportions. So we're going to do the same thing. Let's do a work backwards problem with means this time. So it just says this: administrators at your school want to estimate how much time the student would spend on an average during a typical week. They want to estimate mu, which is the mean of the population, at a 90% confidence interval with a margin of error. So check this out. A margin of error at most 30 minutes. A pilot study indicated that the standard deviation of the time spent per week is about 154. So check this out. So they're saying this is a pilot study. they are projecting this to be the actual population standard deviation. So if they're giving me the population standard deviation, I should be doing a z interval, not a t interval anymore, right? How many students need to be surveyed? Okay, remember, here's what a z interval would look like. It's x bar plus or minus z star times standard deviation of the population divided by the square root of n. But they didn't say calculate the whole confidence interval. They only said calculate the margin of error. Remember, this part right here is called the margin of error. So we're going to take that and set it equal to 30 because they said no more than 30. All right, so let's set it up real quick. So here it goes. Z star. How do I go find a Z star? Go to your Z table. Right? So we're going to have a Z of 1.645 times standard deviation is 154. They told me that ahead of time, the square root of n, and that should equal 30. And now you're ready to do algebra. Right? It's going to be very similar to what we did yesterday to carry out the algebra on this right quick. So let me do real quick. Let me rewrite this. Let me have you see if you can. This is a good test for you guys. See if you can actually calculate the value of n on that. So take a minute, if you got your calculator, see if you can calculate the value of n on this one right here. See if we get the same answer. I'm going to do it without showing all the algebra steps. All right, so this is what I get, 71.3. See if you get the same thing. So again, it's really the setup piece of that, but just make sure that you're doing your order of operations correctly. All right, so that would be your first step, and then I'll just kind of do the next step here. I would do square root of n, square root of n. So you get 154 equals 30 over 1.645, square root of n. Then you're going to divide both sides by that 30 over 1.645, and then the last thing that you do is hit your square button. You're going to square that value to undo the square root. And when I do that, I get an n equals 71.3. Remember what we said yesterday is always round up. When you're talking about people, you always round up. No matter how close that is to 71, my actual answer will be 72. Always round up. Okay. So here's what I want you to do is I'm going to put up one more problem here and have us try and do that second problem. It's the one that's, if you wanted to see it on your syllabus, it's listed as a group, big group. All right, on this, I just want you to do, again, just the number two only. Again, I see it's a means problem. I see they give me the standard deviation of the sample, so this is a t distribution. A t distribution. So I'd say for the first check, right, because we don't even have a data set to look at, since it is such a small sample size of 9 laps, it does say that it follows a normal distribution. So we're going to say that they have looked at the data and it looks good, right? So there's no outliers, no skew. So there's one of our checks. I'm going to keep going here. So it looks like our checks are going to check out, right? Follows approximately normal curve, so that means no outliers, no skew. Random sample. We're going to assume that all laps observed, he's observed more than 90 laps, and it does say has done over 50 track days. So however many laps you see during the day, he's done over 50 of those, so that sounds safe to do. Go ahead and put everything else together there. Now hopefully you saw it, like if you're using your calculator, when you do t-interval, you're going to have to do the stats section, not the data section, because you don't actually have data to put in there. So stats section and put in exactly what they say to put in there. All right, so that's what it kind of should look like. There's your setup there. So again, really I guess you can say the hardest part right now is looking up the critical value, because everything else is given to you, right? They gave me the mean, they gave me the standard deviation of the sample, they gave me the sample size. I use the calculator function here, just the t-interval calc function. Plugged it in and let it do the work for me, right? So that's what we're looking for here. That's what you're trying to assess. So as you do your Khan Academy, they're going to look through some of these pieces. As you do the MyOpen Math, sometimes it's going to focus on, hey, just go look up the t critical value, right? So go look up that the 1.860. Or sometimes it's going to say, go ahead and just calculate the interval. Go ahead and just do t interval or z interval in your calculator. Sometimes it's going to ask you to do the assumption checks, right? What are the checks that I need to do? Every once in a while, you have to work backwards, right? Like the problem that we did for an example. All right, so that's the stuff that we got. So you guys have a little bit